Welcome back. In our last class, we introduced the three laws of motion, and now we're going to apply those laws of motion to analyze the forces on a number of groups of objects. To solve these problems, what we're going to do is we're going to draw what is called a free body diagram that lists all of the forces acting on an object. It's a good idea to draw them out, so the first two or three problems that you're going to do, they'll probably be simple enough that you can probably just see the answer straight away. But as we build up to more complex problems, you really won't be able to do that. So it's really good to be systematic about this, so as you go through these first more simple problems, that when you get to the more complex problems, you have the skills to solve them. So yes, we're going to build up from some simple to solve problems to more complicated ones. So I really want you to practice with these simple ones, and then we're just going to build up gradually step by step, so it shouldn't be too taxing. So I'd like to remind you again that we're going to use this two subscript notation, so as shown here, and the way that works is, so for example with the weight force, so we have the weight subscript 1e, so this is the weight force on block 1 by the Earth. So the W here stands for weight force, and the block 1, so that's whatever object we're considering that we're having a force on, and then the thing that is causing that force, so the gravity force is caused by the Earth. So yeah, this is usually going to be the first force we draw, since we're always going to be looking at objects on the Earth, so everything is going to have this weight force. The normal force, which is a pushing force, so here this normal 1, 2. So in this case, if we have block 2 pushing on block 1, then we would call that a normal 1, 2, the normal force on block 1 by block 2. We're also going to use tension forces. So normal forces, those are going to be pushing forces. So whenever you have two surfaces sort of touching each other, then that's going to be called a normal force. When you have a rope or something pulling on an object, that's going to be a tension force. We're also going to look at friction forces in a little bit. So there we're going to use a lowercase f, and that's going to stand for friction. So now we want to solve one of our problems where we identify all of the forces acting on an object. So in this case, we have our block 1, and block 1 is resting on a surface, and so a hand here is pushing down on our block. So, and we're given the mass of the block, and we're given the force that the hand is applying. So the question then is to identify what are all of the forces and their magnitude and direction on the block. Okay, so in order to do this, we do this in a two-step process. So the first step in this is we want to draw our free body diagram. So that's the first thing we want to do. And so in our free body diagram, we want to basically just sketch something out. So I'm just going to use a block here or something. And I'm going to then draw arrows to indicate the different forces that are acting on our block. So let's look at them. Well, the first one is the weight force. So this is weight 1e. So this is going to be for pretty much all of our objects, right? There's going to be a weight force on them since they're on Earth. So that's going to be one force. The next force we have is the force from the hand. So the hand is pushing on the block. So for pushing forces, we call those normal forces. So this is going to be labeled normal 1h. So it's the normal force on block 1 by the hand. So then, we have one more force to think about, and that is the surface. So the surface is preventing this block from falling through. So that means that we've got a force pointing up, and this is the normal force on 1 by the surface, since also the surface is pushing on the block. So that identifies our three forces here. So this one's not too complex, but you can imagine as we add more and more objects, then these kinds of diagrams can be more complicated. So the second step in our process is we want to use the second law of motion, so the idea that the sum of the forces is equal to the mass times the acceleration, and use that to identify any forces that we don't know the value of. So step 2, we use so this is our sigma, so this is the sum of the forces are equal to the mass times acceleration. So this is going to be split into two directions, right? So in the x direction and the y direction. So the thing is, in the x direction, there are no forces in the x direction. All of our forces are up and down. So this is just going to be 0. So for this particular problem, we can ignore that. Eventually, we'll have some forces in the x direction. So that means we can focus on the forces in the y direction, and that is equal to the mass times the acceleration. So notice, in this case, our block rests on a surface, so it is at rest, it's at equilibrium, so there is no acceleration on the object. So our acceleration is 0, so these net forces are going to add up to 0. So, all right, so to do this, let's identify the values of our forces. So our first force is weight 1e. So to find the weight 1e force, so the weight force is equal to mg. So our mass is 1.5 kilograms times 10 meters per second squared. So that's going to be 15 newtons. And this is pointing down. So yeah, the value here is going to be negative to indicate that the weight force is pointing down. Next we have the normal force by the hand. So the value of the normal force by the hand, so we're told it's 20 newtons and it is pushing down. So because it's pointing down, this is also going to be 20 newtons. And then our last force is the normal 1s force. And for the moment, we don't know the value of this. Now, that means that the sum of these, so we're going to just kind of go up and down like elementary school math. So, the weight 1e plus normal 1h plus normal 1s has to equal the mass times the acceleration, and that is 0 newtons. So this means that negative 15 newtons minus 20 newtons plus normal 1s is equal to 0. So we can solve for that. That has to be 35 newtons. Otherwise, it doesn't all add up to 0. So basically, we know 3 of these 4 values, and then we just solve for the 4th one. So that's the strategy here. So basically, we draw the free body diagram, we identify the forces, then we use the fact that the sum of these forces is equal to the mass times the acceleration, so we can then identify it. Notice another thing here, that we're looking at the hand pushing down on the block. So you can sort of imagine if, like, the surface here was a scale, the normal force is sort of, you know, how hard that surface is being pushed. And so what that means is that, you know, if you're pushing down on it, then the force here is 35 newtons. If we didn't have this hand, if we removed this, this would become 0 newtons, and then the normal force would then be 15 newtons. So that means as you push down harder with your hand, then the normal force on one by the surface increases. So just like if you put something on a scale and you start pushing down on it, then the weight will kind of increase. It's not actually the weight, it's the normal force that the scale is exerting on your hand. All right, so you have some questions to do, so good luck with that. And next we're going to look at a little more complex problem like this.